And I am going to teach you how to figure out what the limiting reactant is in a chemical equation, and also what an excess reactant is. Now, I hope that you watched the YouTube video that I linked in Schoology, but if you didn't, please just pause this video and go back and do that. He goes over a couple of things on how to figure out what a limiting reactant is. The gist of it is this: if you are in your kitchen and you're making a cake, you have flour, eggs, sugar, and all that such stuff, but sometimes you run out of an ingredient. So the ingredient that you would run out of first would be your limiting ingredient. We call that the limiting reactant in chemistry. So what I have given to you is kind of a cheat sheet that you see in front of you. You could have used this for any of the mass-to-mass problems, mass volume problems, or anything like that. Most of you probably already figured this out, that you can set up a dimensional analysis problem very easily once you know the steps to it. So what I'm going to do is I'm going to use the top mass-to-mass little cheat sheet equation thing for you, and I'm going to go over the first two problems on your worksheet that I gave you. So number one, identify the limiting reactant when 1.22 grams of oxygen reacts with 1.05 grams of hydrogen to produce water. So the first step of all these is, just like before, you have to balance the equation, and this is a 1 to 2 to 1. For the first part, notice that the given grams in A. Well, you're given two different sets of grams here. You're given 1.22 grams of oxygen or 1.05 grams of hydrogen. It doesn't matter which one you choose. I'm going to show you that you can find the same answer even starting with either one. So the first one I'm going to do is I started with oxygen. So with the power of computers and font colors, I can show you where this goes. So I'm starting out with 1.22 grams of oxygen. If I have 1.22 grams of oxygen, I need to cancel it out somehow on the bottom with the formula mass of the compound that I have. So I started with oxygen in grams. I'm going to end with oxygen in grams here. And that amount in the formula mass is equal to 1 mole of that compound. Now I'm at moles. So the next part is our mole to mole conversion. So we have to go from moles of oxygen to moles of hydrogen. And in order to do that, we're going to be using our coefficients from our equation. So the number for the coefficient for oxygen is 1. So 1 mole of oxygen to 2 moles of hydrogen. So here is my second compound. So now that I got to moles of hydrogen, I need to cancel out moles of hydrogen. 1 mole of hydrogen is equal to the formula mass in grams of hydrogen. So now that everything is set up, let's talk about what even all of this math even says. So if I use all of the oxygen that's given to me, I use 1.22 grams of oxygen. My answer is going to tell me how many grams of hydrogen I also need to use. So if I do my calculations with this and find out where this is, I end up with 0.15 grams of hydrogen I need to use if I use all of my oxygen up. So you're saying, okay, well, that's great, Ms. Kress, but what do we do with that number now? Well, this number I need to compare to the amount of hydrogen that I was given. I need 0.15 grams. I have 1.05 grams. So what this is telling me is that I have more than enough hydrogen to get me through this problem. And what that means is that hydrogen is actually the excess reactant. So that's the one we have the most of. If hydrogen is the excess reactant, then oxygen is going to be your limiting reactant. So we say O2 is your LR, or your limiting reactant. So what if you started with the other grams that was given to you? Well, if you do that, you're going to get the same answer. You can do it twice if you want to. You really don't have to, as long as you can answer the question. So if I start with 1.05 grams, I'm going to use the same information that I have up here. I'm just going to flip-flop it. So everything is the same. It's just flip-flop. So I have my grams of hydrogen to moles of hydrogen. I have my mole to mole ratio here, 2 moles of hydrogen and 1 mole of oxygen. And then I got to convert from 1 mole of oxygen to grams of oxygen. Once I do that, oops, get rid of that. Who put that there? Once I do that, I'm going to get 8.39 grams of oxygen. So again, just like the first set, I'm going to look at the number that I'm given compared to the number that I need. So if I use all of the hydrogen that I'm given, 1.05 grams of hydrogen, I need 8.39 grams of oxygen. Do I have 8.39 grams of oxygen? No, I do not. So again, same answer as before. Oxygen is going to be your limiting reactant. If I could get this. Oh, formatting. There we go. Is my limiting reactant. And I just shorten it to LR when I'm writing it in class. So that is your limiting reactant. All right, so for a second problem, same thing. You have to balance the equation first. So I'm balancing first. Hey, guess what? Easy equation. I have 4.68 grams of iron, and it reacts with 2.88 grams of sulfur. So again, it doesn't matter which one you start with, just start with one and then fill in your information. Like I just said at the beginning, this goes for everything. So I'm starting with what I have. I need my formula mass in grams for iron, which goes to 1 mole of iron. I have to go from moles of iron to moles of sulfur, because I need to figure out how much sulfur do I need if I use all of my iron up. Well, guess what? It's a 1-to-1 ratio because of the balanced equation, which is nice. 1 mole of sulfur is equal to the formula mass in grams of sulfur, which is that. And then you put it into a calculator and you get, why is that crazy number there? I don't know. 2.69 grams of sulfur. So if I use all of my iron, 4.68 grams of iron, I need 2.69 grams of sulfur. Let's go back up here. How many grams of sulfur do I actually have? Oh, I have 2.88 grams. So what this is saying is sulfur is going to be your excess reactant. And if sulfur is your excess reactant, then that means that iron, or Fe, is your limiting reactant. I hope this helps you guys out. If I was going a little too fast, that's okay. You can always pause this, redo it, go over it, revisit it, and see if you can pick it up later. So with that,